Hello, today I'm going to be doing a video just focusing on how to solve triangles. So we have two main categories. We have our right angle triangles and our oblique triangles, so basically just not right angles. So when we have a angle triangle, we will either use the Pythagorean theorem or SOHCAHTOA. So the Pythagorean theorem is a squared plus b squared equals c squared, where c squared is the hypotenuse, the largest side. So we have this example here, where we have 2372 as a hypotenuse, and we have x. So we know that a squared plus b squared equals c squared. Let's say that our x is our a squared, so x squared plus, and we'll say 23 is our b squared, equals c squared, then substituting in. So you have x squared plus 23 squared equals 72 squared. And I'll have to go grab my calculator. So x squared plus 529 equals 5,184. Then we subtract 529. So x squared equals 4655, and we take the square root of both sides, and that will give us x equals 68.2 approximately. So that's the approach for a right angle triangle where you have two of the sides. If you ever have a right angle triangle and you have a couple of the sides and an angle, or you're looking for an angle, you can use SOHCAHTOA. So we're trying to solve for theta, this angle here. And so we have SOHCAHTOA, which means sine is opposite over hypotenuse. Cos stands for adjacent over hypotenuse. And tan, TOA, stands for opposite over adjacent. So looking at this angle, we have the opposite angle and we have the hypotenuse. So that means we'll be using sine. So sine of theta equals opposite over hypotenuse, so that would be 11 over 18. And then we just have to inverse the sign, so we go to our calculators and hit the second function button, and then the sine button, and then times it by 11 over 18. And that will give you theta equals theta equals 37.67 degrees approximately. Alright, now we're going to get into our oblique triangles where we do not have a right angle. So starting off with sine law. So sine law states that sine A over sine A equals sine B over sine B, which equals sine C over sine C. The capital letters are the angles and the lowercase letters are the side lengths. So basically, the way I like to approach these questions is if you have an angle on the opposite side, like I like to do like a little like circle around it to sort of like pair it off. Then we also have one over here. Sorry, it's a little bit difficult to see. We have x and 30 degrees and 20 and 40 degrees. One thing I forgot to mention, you can also invert this formula. So a over sine A equals b over sine B equals c over sine c. So you can invert this formula. So x over sine 30 equals 20 over sine 40. So now we just multiply that by sine 30. multiply both sides by sine 30. Now give us x equals one thing I forgot to mention. Whenever we're using degrees, make sure that your calculator is in degrees when you're using the sine, cos, and tan buttons, or else you'll get something completely different. So that first example, we found a length. This time we're going to find an angle. So I'm going to do the same sort of approach. Maybe I'll highlight them. So we have this 10 degree, and we have the opposite side length here. And then we have our angle theta and 42. So sine of theta over 42 equals sine of 10 degrees over 20. So now we're going to multiply by 42. So sine theta equals 0.364. Now we're going to do the inverse of sine. So second function sine of 0.364. And that gives us a value of 21.35 degrees, depending on where you rounded. All right, so that is the approach for sine law. So cosine law. Cosine law, you use it in two situations. One is where you have all three side lengths and no angles, or if you have an angle, what we like to call a enclosed angle. So we have this 60 degrees here, and then we have the two side lengths on each side of it. And so, yeah, c equals a square root of a squared plus b squared minus 2ab cos c. It can also be wrote as c squared equals a squared plus b squared minus 2ab cos c. And then there's also another form where it's rearranged to solve for the angle. But starting off with this triangle here. So, so c equals square root of a squared plus b squared minus 2ab cos of c. So this means it equals, just like the Pythagorean theorem, it doesn't matter which of these two letters is a or b, they're interchangeable, just, yeah. But the c value is important because it's paired up with this angle here. So we have 10 squared plus 12 squared minus 2 times 10 times 12 times cos of angle c, which would be this angle here, that is opposite from our side length c. So that would be cos of 60 degrees. And if you crunch all those numbers, you'll get approximately 11.14. So next up, we have a situation where we don't have any angles, but we are trying to, but we have three side lengths. So we are looking for this angle c here, so we're going to rearrange this formula. So we have c squared equals a squared plus b squared minus 2ab cos c. You may be given this formula, so you might not have to rearrange it, but yeah, it depends on who your teacher is, I guess. So we are going to rearrange for our cos c. So we'll have c squared minus a squared minus b squared equals negative 2ab cos c. Now we're going to divide by negative 2ab. And I'll give us yep, so that'll give us a squared plus b squared minus c squared over 2ab. So I just divided those negative out and just flipped the signs and reordered it a bit. Now equal cos of c. So cos of c equals a squared. So this is our c value here because it's opposite of our angle, and then either of these can be a or b. So that will give us 12 squared plus 10 squared minus c squared, which is 8 squared, over 2 times 10 times 12. And this equals 0.75. Now we have to, here, I'll move that down here. Now we have to do our inverse of cos. And once we do that, we will get that c equals 41.41 degrees. So this is just a quick video going over different ways to solve triangles, starting with the Pythagorean theorem and SOHCAHTOA for our right angle triangles. Pythagorean theorem specifically, if you have two side lengths, you'll use it. SOHCAHTOA, when you have a couple side lengths and an angle. And then once we enter our oblique triangles, like our triangles without a right angle, if we have pairs of angles, like say we had A and A here, and then a side length, then we use sine law using our pairs of angles and side lengths. And finally, we have cosine law when we have either an enclosed angle like this, or 3 side lengths and no angles. But yeah, that wraps up this video. If you guys have any questions or want me to cover anything in particular, feel free to let me know.